So we covered the properties of amines. Okay. Isomeric amines with the same what we discussed in the properties is that if you have same molecular weight, same for amines having uh, same molecular weight, same formula for those amines, primary, secondary, and tertiary. Primary is going to have the highest one, and the tertiary is going to have the lowest one. Got it? If you take an amine and an alcohol of approximately or nearly same molecular weight, the boiling point of the alcohol is going to be higher. Got it? Is it clear? And, because alcohols can form stronger hydrogen bonding than the nitrogen. If we compare the water solubility, the primary amines are most soluble. Is it clear or not? So we have covered the physical properties of amines. Let's move on to the chemical properties. So Aisha and Marwa, can you tell me what are the chemical properties of amines? What type of reactions do they give? Hmm. Yeah, am I audible to all of you?
Yes.
Okay. So I was discussing what are the chemical reactions, what type of chemical reactions amines can give.
With acids.
Hmm. That is the basic strength. Basic strength of amines. Amines act as Lewis bases. Got it? And they react with salts. To form they react with acids to form ammonium salts. Is it clear? They act like a basis. They react with acids to form ammonium salts. Is it clear? So suppose what are we going to get if you react NH3 with HCl? Can you tell me? What are we going to get if you react NH3 and HCl?
Ammonium chloride.
Yeah. So this is we are going to get NH4 plus and Cl minus. Got it? So we get ammonium chloride. This is the salt. Suppose if you react with H2SO4, what is going to be the equation for it? How many moles of amines are required? Yeah, Isha, Marwa, tell me. How many moles of amines? This can give 2H plus. I hope all of you agree with it. Okay. And if you get 2H plus, how many amines we need? Any idea? How many moles of amines can react with H2SO4? 1 mole of H2SO4. Yeah, Isha. Marwa, tell me. How many moles of amines are needed? One NH2 can accept one H plus. Got it? So I need two of them. Is it clear?
Yes.
So two of them, and we are going to get this salt. 1 mole of salt with an anion sulfate, and it is CH3NH3 plus whole plus. Got it? Is it clear or not?
Yes.
So this is again acid-base reaction. We need to compare the basic strength of amines. Is it clear? So what are the basic strength of amines? That we need to compare. So if you compare means basic strength, it is equivalent of saying which amine is stronger base and which amine is weaker base. Got it? So any idea about the basic strength of amines? Yeah, Aisha, Marwa.
So they're stronger than water. They're stronger
Yeah.
bases.
Yeah, they are more basic than water. Exactly, absolutely. And they are more basic than water. That's true. And if you try to compare the basic strength of primary, secondary, tertiary amine with ammonia, how can you arrange them? Suppose, let's say, if I take methylamine, got it? So if I take methylamine, CH3, and if I compare it with CH3, NH2, okay? So CH3 whole twice NH, right? And CH3 whole thrice N. This is a tertium. So how can you compare the basic strength? I hope you understood my question. Which
Yes,
amine
sir.
is going to be more basic and which amine is going to be less basic? So compare the basic strength of amines, okay, in aqueous medium, that is water. So how can you compare the basic strength in water? What you are going to look for when you are comparing the basic strength? Suppose if you put an alkyl group is electron donating or withdrawing? Yeah, Ishan Marwa, tell me, is it electron donating or withdrawing? Alkyl group,
Donating.
donating. Okay, so if it is donating, it will make the amine more electron rich. Is it clear? It is going to make the amine more electron rich. And if it is more electron rich, it is going to be more basic. Is it clear? But every time the things don't move in the proper direction, actually the expected trend is CH3 whole thrice NH, that should be most basic. Okay. This is the expected trend. But that is not the answer. Is it clear or not? The answer is there is a some change. Actual basic strength. Is it clear or not? Why is it so? Why the basic strength is fluctuating like this? What's the reason? Yeah, Isha. Why the tertiary amine, in spite of having three alkyl groups, it is not very basic? Any idea what's the reason?
Sir, can you repeat?
Pardon?
Can you repeat?
Yeah, why this is not very basic? Why it has moved backward? Got it? Why it's not very basic? What's the reason? Tertiary amine is having three alkyl groups, right? So it should be maximum basic, followed by secondary, primary, and then NH3. Okay. But the tertiary amine is not a very strong base. It is just next to NH3. Can you see it?
Yes.
So what's the reason? There is one more
It
reason.
is
Yeah, tell me.
the number, like the hydrogen atoms.
Yes, exactly. In water, actually, there is one more thing which is playing an important role. Water is a solvent, very good solvent, all of us know. And we also know that water in bio also, you may be studying that it is a good solvent because of the hydrogen bond. Okay. So the effect of hydrogen bonding is reversing this order. Okay. So due to H bonding in water. So why it is not so basic? Because the tertiary amine NH is not having NH bonds. So it cannot participate in hydrogen bonding. Secondary amine, primary amine, that is okay. Okay. So this is as per the trend. Is it clear? Suppose if NH3 accept the H plus, it forms ammonium ion. And if it forms ammonium ion, that ammonium ion is going to make 4 H bonds. Okay. And but this tertiary amine is going to make only 1 H bond after accepting H plus. So that effect of H bond is not as high as what we expected in tertiary amine. As a result, tertiary amine is less basic. One is due to bulky groups, and due to less number of NH groups. It has become less basic. Is it clear or not? So this, it is better for you to remember this, because this whole discussion is not going to be examined at the time of answering the question. Many times you have just a question, you need to just explain it that it is because of the intram, that is, it is because of the hydrogen bonding, it has happened. The tertiary amine is having 3 alkyl groups, but the NH bonds are not many. That's why it is not a very strong base. Is it clear or not? Any doubts in this? Aisha, Marwa, any doubts?
No, sir.
Okay, good. Suppose if I ask you to compare the basic strength of aniline. Aniline, what is the other name for aniline? It is benzenamine and cyclohexanone. Got it? Which one do you expect to be more basic? And what is the reason?
So the one with the rings because of resonance.
The right one is more basic or the left one is? Aniline, this is aniline.
Yeah, aniline.
It's more basic.
Yeah, because of the resonance.
Yeah, but because of the resonance, what has happened? Now its lone pair is more available for the H plus or less available for the H plus.
Like the lone pair of the electrons, they're withdrawn.
Yeah, and they will get into the ring.
Yeah, they
And if
share
they
with the
get into
partner.
the ring, yeah, if they get into the ring, they are less available. Got it? Though aniline, so it is less available. Is it clear? So because it is less available, is it clear or not? Look what has happened. Aniline, the lone pair, I should say it is delocalized. This lone pair will form the ring, double bond with the benzene ring. This minus charge is how I am writing these resonance structures. This lone pair, when it tries to make the bond with this carbon, it pushes away the pi bond to the adjacent atom. So both the electrons of this double bond get shifted onto the adjacent atom, and that's why you have a negative charge. This negative charge can move further and try to form bond with the other carbon atom. The pi bond will get shifted onto the next atom. Is it clear? The para position. So initially it was at ortho position. Now it is at para position. Is it clear or not? And after the
Yes.
para position, it can get onto the ortho position. Clear? This is the next ortho position. It can push the pi bond, double bond to the next carbon atom. Marwa, is it clear or not?
Yes, sir.
So now it is going to push that original double bond and it is going to come again on nitrogen. So you have that this is a very, very important structure. Okay. These are the resonance structures of aniline. Do remember it. and it is showing the delocalization of lone pair of NH2. Lone pair of NH2 is delocalized. In the benzene ring. Delocalized in the benzene ring means what? Delocalized in the benzene ring means it has moved into the benzene ring at ortho and para positions. Is it clear? If you try to look at the actual structure will be the hybrid of all these structures, which is known as resonance hybrid. And it will have negative charges and a positive charge on NH2 and negative charges on ortho and para position. Because if you take the average, you can see that this is ortho, and this is para. And the charge is moving through these positions. So overall, there is some increased electron density at ortho and para positions. But as far as basic strength is concerned, what has happened to the lone pair of nitrogen? What has happened to it? Is it now more available or less available? Tell me quickly. Is it more available if it is available at one place? But something, if it may have distributed, it may be its availability may have gone down. Got it? Suppose if something spreads at multiple positions, so what will you say? Will you say that it is more available or less available? If something spreads, got it? And you can see the lone pair is spreading onto the multiple position due to resonance. Is it clear or not? So what has happened to the basic strength? Okay. What has happened to the basic strength? Is it more or less? Has it increased or decreased? Tell me. Because of resonance. It has
increased.
no.
No.
Suppose it has decreased. Why? Look, suppose if I take aniline, okay, and suppose if I have taken aniline, and if I react with H plus, because I'm considering it to a base, it will react with HCl. HCl I can write it like this. Okay, mainly it is the H plus. So the lone pair is being donated to the H plus. Is it clear? You will get anilinium. This is the salt, anilinium chloride. But what has happened due to resonance? Due to resonance, the lone pair has distributed itself onto the various positions in the benzene ring. Got it?
Yes.
So now it has become more basic or less basic. Can you think of it again? If if it is lone pair is not fixed at one place, if it is moving here and there, how it can be donated to H plus? Understood or not? Basic strength has decreased due to resonance. Got it? Any doubts in this?
Yes.
Marwa, Aisha? So could you just summarize what has happened by due to resonance? Has the basic strength decreased or increased? What will you write? Is what do you expect the aniline to be more basic or less basic than the cyclohexylamine, where the lone pair is fixed, it is not moving, it can be donated more easily to the H plus. Got it? Is it clear or not?
Yes.
But in the case of aniline, the lone pair is actually not fixed, it is moving and it has gone at many places. And if it has distributed itself at many places, what it means? It has become less basic. Got it? So aniline, the basic strength is decreased due to resonance. Is this clear or not? Any doubts in this? Aisha, Marwa, tell me quickly.
Yes, so clear.
Okay. And suppose if you have some electron donating groups, electron donating groups are the groups these are the groups which can give electron apart from NH2. The basic strength is going to go up. The basic strength is increased. Is it clear?
Yes.
And if you have electron withdrawing group, which can take away the electron further from the benzene ring, the electron donating groups are like OH, the lone pair containing group, OCH3. Got it. These are some of the electron donating groups. CH3. They make the amines more basic. On the other hand, electron withdrawing group, electron withdrawing group will pull the electrons towards themselves. They do not have lone pairs on them. Instead, they have double bonds and more electronegative atoms. SO3H. So these are electron pulling groups. Got it? And they are going to make the amines less basic. Lone pair is delocalized further, so its basic strength is going to come down. Got any doubts in this? And if it is not doing resonance, if it is an aliphatic amine, aliphatic, this is an aromatic amine. Got it? And the resonance, because the lone pair is not fixed, it can move into the benzene ring. Okay. And because of that, its basic strength has gone down. And if you put some more electron withdrawing group, its basic strength is going to go down further. Is it clear or not? Okay. Next is, and for aliphatic amines, means methylamines, the basic strength is NH3, and which is the lowest basic, least basic, then CH3 whole thrice N, methylamine, and dimethylamine. So in water, in aqueous medium, the secondary amines are most basic. Remember that. It is occurring due to hydrogen bonding. Because in water, NH3 can form NH4 plus. Okay, it can form 4 hydrogen bonds. So it has become more stable. And the tertiary amine can form only 1 hydrogen bond after accepting H plus. So it is not very stable after accepting H plus. So that's why it is not very basic. Is it clear? So let's move on to the other reaction. What is the other reaction of amines? The other reaction is very, very important, and its name is acetylation. Okay. So Marwa, what this acetylation means?
Yes, sir.
Or acylation? Yeah, tell me. What it means? Acetylation or acylation?
Acetyl is that is adding an acetyl group.
Yeah, addition of which group? CH3 COCl. Got it? Or addition of COCH3, because that Cl will be removed with HCl. So putting COCH3 is known as acetylation or acylation. Okay, got it? Primary and secondary amines can undergo acylation, right? Tertiary amines cannot undergo acylation or acetylation. Why? So I will write the reaction, and once I write, you will be able to make out why the tertiary amines cannot undergo acetylation or acylation. It is due to the absence of got it. So look how it happens. Suppose you have taken an amine and you have taken CH3COCl. This is the acetylating agent or acylating agent. You take some base base removes HCl. If you remove HCl, you have COCH3 group attached in place of one hydrogen. How you are going to do it? Write it like this. Make this CH3COCl appear in the reverse manner. Remove HCl. Got it? So if you do this, you will observe that your amine is now acetylated. Okay. It is N-methyl. This is ethanamide. And on nitrogen, you have a methyl group. So N-methyl methanamide. Is it clear or not? So why tertiary amine can't undergo acetylation? What's the reason? Yeah, Aisha, Marwa, tell me. Why the tertiary amine can't undergo acetylation reaction? If I write the structure of tertiary amine, is there any hydrogen which can be removed? Tell me. Look what we are doing. Can everybody see it?
Yes.
What are we doing? We are removing HCl. On tertiary amine there are 3 alkyl groups. Is there any H available which can be removed?
No, sir.
No H is available. So if I react it with CH3COCl, will it undergo acetylation reaction?
No, sir.
No acetylation reaction. Got it? Acetylation can be carried out with the help of what is the acetylating reagent? What is the name of this acetylating reagent which is causing acetylation to happen? Tell me quickly.
A base.
Base is actually causing the absorbing the HCl. It is removing HCl. But who is responsible for what is the reagent which you are taking with the amine which is causing acetylation? It is acetyl chloride. Got it? So who is causing acetylation? Acetyl chloride is causing acetylation. Okay. Or you can use the acetic anhydride also. For example, if I take aniline and if I react with CH3COCl, what will happen? HCl will be removed. And this is acid chloride or acetyl chloride. This is the acetylating agent. I will use the pyridine for the removal of HCl. This is aniline. And this one is acetylated aniline. So acetanilide. Is it clear or not? Any doubts in this? Suppose what could be the other acetylating agent? There you removed HCl and here you are going to remove acetic acid. So what are you going to get? There we removed HCl. In this case, we are going to remove CH3COOH. This is known as acetic anhydride. This is the other acetylating agent other than acid chloride. The above one is acid chloride, carboxylic acid chloride, which is the name of the function group. The actual one is acetyl chloride, and this next one is acetic anhydride. Got it? Is it clear or not? Any doubts in this? Tertiary amine cannot undergo acetylation. Okay. Because we know that they do not possess any hydrogen. Now, suppose what is the answer to this problem? Tell me quickly. This is same as that of this reaction, but little bit different, not exactly same. CH3NH2 PHCO CH3COCl. So Aisha, tell me, what are you going to do with it? Just follow the same strategy which we are doing in the above question. Tell me quickly. Marwa, tell me. Aisha, tell me how we are going to write the product. Yeah, Aisha.
Is it CH3CO and then
Look, we have CH3 and N. Got it? So first write this one. Do it in parts. Okay. Remove one H and remove the Cl. Got it? And just flip that molecule with Cl on towards the side of NH2 and remove the HCl and connect both the molecules. Is it clear? I have flipped it CO and pH. Got it? PHCOCl I have flipped it so that the Cl comes toward the NH2 and remove that HCl. That same strategy which we have followed here. Can you see? This one. That same strategy we are adopting here also. Any doubts in this? But this is this acetylation or is it something else? And what it is? What the name say? It is similar to acetylation, but the group is not acetyl. Can you see? Acetyl is CH3C double bond O is acetyl. This is which group?
Alkyl.
Benzene and CO. Got it? So this is acetylation, not acetylation, similar, but the reaction type is same. Okay, that's what we know. This is benzoyl chloride. Okay, benzoyl. So this is that was acetyl chloride. So the name acetylation. This is benzoyl chloride. So the name of the process is benzoylation. Is this clear to everyone? Attachment, this is the benzoyl group. Clear to everyone? And it has a name. It is short and Bowman reaction. Got it? So let's do some question. What are we going to get here? What should be the reactant? Which hmm.
So option C.
Option C or D? Look who is there on the nitrogen in the product.
Oh, sorry, option D.
Option D. Yes, absolutely correct. Because only the hydrogen and the Cl got removed. Okay. So this is dimethylamine. Okay. And this is the right answer. Is it clear or not? Marwa, are you getting it?
Yes, sir.
Okay. So is it acetylation or benzoylation? You can look at the reaction and try to figure out. Is it the acetylation or the benzoylation? What is getting attached to the nitrogen? Is it the acetyl group or the benzoyl group?
Acetyl.
No, check once more. Acetyl is CH3, C double bond O. And this is which group? This is phenyl, benzene ring. Got it?
Mm.
Benzene and CO. That is benzoyl. Is it clear? Can you
Yes.
see the benzoyl group? So this is benzoylation. Got it? I hope it is clear to everyone. This is benzoylation reaction of dimethylamine. What is the other name for the benzoylation?
Cotton-Bowman reaction.
Yeah, Schotten-Bowman reaction. Exactly. So Schotten-Bowman reaction is the other name for benzoylation. Okay, got it. So, but tertiary amine can never undergo neither acetylation nor benzoylation because tertiary amine, because if you are attaching some group to nitrogen, you need to remove one hydrogen and there is no hydrogen. Got it? So that reaction is not going to happen. The same, both the reactions are not going to happen for tertiary amines. So let's move on to the next reaction. Okay. The next reaction is a very important reaction. It is used as a laboratory test. Okay. Which when a reaction classifies under the category of laboratory test, it can be used for the identification. Got it. So when a reaction can be considered to be a laboratory test for identification of a particular functional group. What's the criteria? Tell me quickly. What's the criteria for a reaction to be considered as a, you may be doing some reactions in the school. If so you try to figure out uh, this particular functional group. Okay, how you try to figure it out? You observe some formation formation of some color
Precipitate.
precipitate. Exactly, very good. Colored precipitate, or it could be evolution of some gas. Okay, with a characteristic odor. Okay, or some color change in color. These are some of the common observation which we need to look for while carrying out a reaction which comes under the category of identification reaction laboratory test. Okay, so we are going to do such reaction, and that is carbylamine test or often carbylamine test. Okay, or just often carbylamine test. or isocyanate test. Got it? And this is used to detect the amines. Okay, how it is used to detect amines and which type of amines? It is used to detect primary amines. Got it? So primary amines are got it. So it is used to detect primary amines and what reaction it involves. Okay, and how they are detected? What's the evidence for this reaction? Okay, that we need to check. So it is first to take the primary amine. Got it? Then the reagent which is used is CHCl3. Is it clear? It is known as, what is this reagent? What is this
Chloroform.
reagent? Chloroform. So you react your amine with chloroform. Got it? And base KOH. So when you heat this primary amine with this is 1 degree amine with chloroform and base, what happens? Okay, some new compound is formed because it is a chemical reaction, so maybe something new must be forming, and that new thing must have some characteristic which may be helping us to detect the amine. And can you tell me what is forming? What this is?
Alkyl isocyanate.
Yeah, an alkyl isocyanide, or the other name for the isocyanide is carbide. Got it? Is it clear or not?
Yes, sir. Yes.
So you end up with KCl. This forms a salt NH2. And what the characteristic of this isocyanate? This isocyanate has a foul fishy odor. And this is the key thing. It helps us to detect the amine. Got it? Because of the foul smell or fishy smell. Amine, primary amine can be detected. Only primary amine give this test. Why secondary and tertiary amine do not give this test? What could be the reason? Yeah, Isha Marwa, tell me. What could be the reason that secondary and tertiary amines may not be responding to this test? Hmm? Look here, the answer lies in the number of hydrogens. Okay. You have two hydrogens on the primary amine. Suppose if you take secondary amine, which is having just one hydrogen, and two methyl groups. Can it form a triple bond with carbon? No. Can it react with chloroform? No. And what about the tertiary amine? There is no hydrogen at all. So it doesn't have any tendency to react. Got it? So primary amine, only primary amine which is having two hydrogen, because these two hydrogens are getting removed, you can see. And a triple bond is being formed with the nitrogen of the amine. I hope it is clear to everyone. Aisha, Marwa, tell me quickly.
Yes, sir.
Any doubts on this? It's a very important catch. Okay. So let's do some questions. CH3KOH. You got A and A you reacted with H2Ni. This is catalytic hydrogenation reaction. You got B. So what should be A and B? A, you know, we are doing as we are doing the reaction. It is directly linked to the above reaction. The structure of A. Can you tell me? What should be the structure of A? Yeah, Isha, Marwa,
CH3 NHC3.
the CH3. It is isocyanate test. Isocyanate test, primary amines when treated. In words, you can write, okay, very, very important. Primary amines when treated with chloroform and base in the presence of base forms a foul smelling substance. Okay. So on one side, keep this structure intact, CH3N. And this chloroform is going to attach to the nitrogen with a triple bond. Got it? NC. And it is a substance which will give a foul smell, fishy odor, and you can clearly recognize that it is a primary amine. In this question, I have written the structure. Okay, but I have written the structure, but if the formula is given, the structure will not be mentioned to you. And if the structure is not mentioned to you, okay, you can just imagine that it is a primary amine. How can you imagine? By realizing that whatever the reaction you did, the product form gave a foul smelling substance. Okay. Is it clear to everyone? Any doubts in this? The structure of A. Marwa, tell me quickly. Marwa, am I audible?
Yes, sir.
So tell me quickly. Is it clear? A or any doubts?
Yes, sir.
Okay. What is the B? Structure of B. What is the structure of B then? I am treated with H2Ni. H2Ni, what H2 and Ni going to do? This is catalytic hydrogenation reaction. Aisha, can you hear me?
Yes, sir.
So what happens with the catalytic hydrogenation reaction? All the double bonds will go and
The
you will have HH connected, okay? So what you will have CH3, NH, CH3. Got it. This one A to B is not that isocyanate test. Only this portion is the isocyanate test. Understood or not?
yes.
Okay. Suppose it will be given like this. An amine whose formula is C3H9N. Upon reacting with CHCl3 and KOH and heating gives a foul smelling substance. Is it clear? The next thing which is given to us is to identify the structure of A and B. Is it clear? So what is the structure of A? It's very simple. First of all, this indicates that foul smelling substance indicate that it is a primary amine. It is a primary amine with 3 carbon atoms. Now the question is it this amine? This is also primary NH2 and not this amine. This is also NH2. Got it? C cannot be the answer because it is a secondary amine. D cannot be the answer because it is a tertiary. Got it? Clear?
Yes, sir.
So whether it is A or B, that is clearly mentioned in the next statement. Okay, this amine can also be prepared by carrying out ammonolysis of 1-bromopropane. This is ammonolysis. Got it? So 1-bromopropane, if you carry out ammonolysis, which amine are you going to get? Is it the propanamine, propane 1 amine or propane 2 amine? It is propane 1 amine. Option A only is going to be the right option. Got it? Because if you have Br on the first carbon, the NH3 also should be on the first carbon. Are you getting my point or not?
Yes.
It cannot come. Marwa, are you getting my point?
Yes, sir.
So this is at the second position, but the halide which is given is at the first position. Okay, so go by that. Okay, and A is the right answer. Okay, so very important. Okay. So let's continue it in the next class. I'm going to give you more assignments. Okay, and we will discuss them also. And just do at least 3-4 questions which I gave in the assignment, because I gave only those questions which are very important. It's very basic and very important. Okay, so we are going to discuss